Hey kids, welcome to section 5.5, graphing cube root functions. Today you're going to learn how to graph cube root functions and how to analyze cube root functions. So the first thing we need to talk about is what the key characteristics of a cube root function are. First of all, the parent function looks like this at the top. F of x equals the cube root of x. Notice that the cube root function kind of looks like a squiggle. Also, keep in mind that the cube function, just for funsies, the cube function tends to look like this. So remember, a cube function and a cube root function should be inverses of each other. And so if I were to reflect the cubic function over the line y equals x, I do get the cube root function. Notice that the domain of a cube root function is all real numbers. That's because I can cube root positives and negatives. Notice that the range is all real numbers. That's because I can get any number out of it. The intercepts are 0, 0. The symmetry, there is point symmetry about the origin. So that means I can rotate this graph and it will be back after 180-degree rotation. Notice that the end behavior is back to what we're normally used to. As x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches negative infinity. There are no extrema, and then we have an inflection point at 0, 0. So this inflection point is the point in the middle where the graph changes direction. That's called the inflection point. We still have transformations of cube root functions. We can still translate things right and left. That's connected with the minus h. We can still translate things up and down. That's still connected with this k value. Notice the h and k are also the inflection point. And we can still reflect it over the x-axis, and we can still stretch and compress vertically. So all of the key characteristics from the square root function and from other functions also apply to cube root functions. So let's take a look and see how we can graph these cube root functions. We not only have to graph the function, but we need to state domain, range, end behavior, and what the inflection point is. So when you're doing a graph for part A, f of x equals the cube root of x plus 3, we want to make a table so that we can graph it. Now, we want to start with the inflection point. So the inflection point, remember, is associated with your h and k. And so this inflection point for part A is negative 3, 0. So negative 3, 0 is what we want to start with first. Then to finish our table, I want to go 1 up. So that would be negative 2. And so if I do negative 2 plus 3, I get 1. And the cube root of 1 is 1. So I get negative 2, 1. If I go down 1 and instead plug in negative 4, so going in the other direction, negative 4 plus 3 is negative 1, and the cube root of negative 1 is negative 1. So I have negative 4, negative 1. This is where it's going to start changing direction. Now let's keep going past negative 2 to the right. So if I plug in negative 1 plus 3 is 2, and I can't cube root 2. So then I want to plug in 0. 0 plus 3 is 3. I can't cube root 3. I plug in 1. 1 plus 3 is 4. I can't cube root 4. I can't cube root the next one until I get to 8, because that's what 2 cubed is. So if I plug in an x of 5, then 5 plus 3 is 8, and the cube root of 8 is 2. So I can get 5, 2. So that was 1, 2, 3, 4, 5, 6, 7 more. So if I back up 7 in the other direction, that's negative 10. And so negative 10, no, actually, I want negative 11. The reason why I want negative 11 is because negative 11 plus 3 is negative 8, and the cube root of negative 8 is negative 2. So negative 11, negative 2. That way I can see what my curve looks like. So you kind of have to play around with the x values so that you can get 0, 1, and 8 when you cube root. Okay, my domain is all real numbers, so negative infinity to positive infinity. My range is all real numbers, so negative infinity to positive infinity. My end behavior as x approaches positive infinity, my f of x is getting larger, so approaches positive infinity. As my x approaches negative infinity, my f of x is getting smaller, so it approaches negative infinity. My inflection point is my h and k, which is negative 3, 0. All right, if we take a look at letter B, f of x equals negative cube root x minus 6 plus 2. Notice that my h and k is going to be 6, 2. That's my inflection point, so I can put that down here. Notice that it's going to be translated 6 units to the right, 2 units up, and it's going to be reflected over the x-axis. So if I make my table, I want to start with my inflection point, which is 6, 2. If I do 1 to the right, that's 7. So 7 minus 6 is 1. The cube root of 1 is 1. Attach the negative 1 to get negative 1, and add 2 to get 1. So 7, 1. If I go and plug in 5, which is 1 in the opposite direction, 5 minus 6 is negative 1. The cube root is negative 1 times the negative 1 is a positive 1, plus 2 gives me 3. Now, I'm not going to really be able to plug too much in on the right, but I can plug some more stuff in on the left. If I want this entire thing underneath the radical to equal negative 8, so I can cube root it, that means I need a negative 2. So negative 2 minus 6 is negative 8. The cube root is negative 2 times the negative is 2, and 2 plus 2 is 4. So I have negative 2, 4. This will give me a better idea of what my graph will look like. The domain is all real numbers, so negative infinity to positive infinity. The range is all real numbers, negative infinity to positive infinity. My end behavior as x approaches positive infinity, my f of x is getting smaller or approaching negative infinity. As my x gets smaller or as it approaches negative infinity, my f of x's are getting bigger, so they approach positive infinity. My inflection point is 6, 2. And notice that the picture is reflected over the x-axis. It goes downward fashion versus letter A, it goes in an upward fashion. And that all has to do with that negative in front. All right. So let's work on finding inverses of functions. So find the inverse of the function, then graph the function and its inverse on the same coordinate plane. Okay, remember to find an inverse, step 1 is to replace f of x with y. So y equals x cubed plus 1. Step 2 is to swap the x's and y's. So x equals y cubed plus 1. Step 3 is to solve for y. So I'm going to subtract 1 on both sides. And then I need to solve for y. So to get rid of the cube, I'm going to cube root both sides. And then finally, I'm going to say that it's an inverse by writing f negative 1 of x is equal to the cube root of x minus 1. All right, let's draw the original in orange. I'll do this one. Okay, so I can make a table. If you have no idea how to graph a cubic, negative 2, negative 1, 0, 1, and 2. Doesn't matter what you plug in because you're plugging into a cubic, not a cube root. So if I plug in negative 2, that's negative 9. If I plug in negative 1, that's negative 2. If I plug in 0, that's negative 1. If I plug in 1, I get 0. If I plug in 2, I get 7. So negative 2, negative 9, negative 1, negative 2, 0, negative 1, 1, 0, and 2, 7. Notice that it looks a lot like the cube root function that we just learned how to graph. And remember, it should because they're inverses of each other. All right, so if you have no idea how to graph the cube root of a function, remember you could just swap x's and y's on the graph. So if we start in my table, I can swap it and get -9, -2. And then swap and get -2, -1, -1, 0, 0, 1, and 2, 7. No, 7, 2. 7, 2. Then if I connect my dots, notice that they are indeed reflections over the line y equals x. Awesome. Let's do one more. Part B, f of x equals -1/2 x cubed. So swap out the f of x for a y. So y equals -1/2 x cubed. Switch the x and y. So x equals -1/2 y cubed. I need to get rid of the -1/2. So let's multiply both sides by -2/1. So that gives me -2x equals y cubed. And then I need to cube root both sides. So the cube root of -2x equals y. And then I can say f inverse of x is equal to the cube root of -2x. All right, so let's switch colors and do the original. So the original, I can plug in -2, -1, 0, 1, and 2. If I plug in -2, that gives me -8 times that gives me 4. If I plug in -1, I get a half. If I plug in 0, I get 0. If I plug in 1, I get -1/2. If I plug in 2, that gives me -4. So -2, 4, -1, 1/2, 0, 0, 1, -1/2, and 2, -4. So here is my picture. It makes sense that it's going down, and that's because there's a negative in front. Oh, you know what? I should probably be labeling these. This is f of x, and this is f inverse of x. This is f of x, and let's do the inverse. So again, if you want to do the inverse really easily, just swap the x's and y's. So 4, -2, 1/2, -1, 0, 0, -1/2, 1, and -4, 2. So here is my inverse, f -1 of x. Awesome. Okay, let's take a look at a word problem. A fruit grower has found that the circumference c in inches of most of his fruit crop can be modeled by the cube root function c equals the cube root of w over 0.009, where w is the weight in ounces. What is the approximate circumference of a piece of fruit that weighs 8.5 ounces? Round to the nearest tenth of an inch. So 8.5 is a weight. Weight is W. So I'm going to replace 8.5 with W, or W with 8.5. So C equals the cube root of 8.5 divided by 0.009. If I type this into my calculator and round to the nearest tenth, I get 9.8 inches. Okay, part B, what is the approximate weight of a piece of fruit with a circumference of 8 inches, round to the nearest tenth of an ounce? So this circumference is my C value. So I'm going to replace C with 8 equals the cube root of W over 0.009. Well, in order to get to the W, I need to get rid of the cube root. In order to get rid of a cube root, I'm going to cube both sides. So 8 cubed is 512 is equal to W over 0.009. I can solve for W by multiplying both sides by 0.009. And so 0.009 times 512 rounded to the nearest tenth is 4.6 ounces. All right, kids, that's the end of section 5.5. If you have any questions, please let me know. And as always, keep calm and keep trucking.